Hello, I'm Arthur. Welcome to my lab. And that's how you make a 3D printer. Now for some software. Before we get to software, however, I would like to talk about a few add-ons, few extra goodies that I added to this printer and to the design. And I will post these files on my Thingiverse account so that you can download them. So of course I needed to mount the main controller board for the printer somehow, and so I just whipped up a quick bracket that the controller board mounts to this bracket using 4 screws, and the bracket itself mounts to the frame using 3 screws right here in these 3 points. So that's how you attach the controller. And then I also have these noise dampening feet that cancel the noise. I don't want the noise transferring to either the floor or the desk, wherever this printer will be sitting. So this is actually a modified version of something that I found on Thingiverse. So I'll post my version. The original version had like a cross bracket. There was another piece going up and down in this direction, but I wanted to keep the footprint to a minimum. So I redesigned this thing to just go under the printer, and also these brackets needed to be a little bit bigger because the original design was a little shorter, a little thinner here, and so my motor was still hitting the surface that it was sitting on. So this is a little bit wider now, and that lifts the motor off the surface. And also I made actually based on the clips that hold these feet to the extrusion, I changed these clips to be just a flat clip, and that holds in place all the wiring. So I ran my wires in this nylon mesh that fits in the opening in the extrusion, which actually works out very nice. And so I needed something to hold this in place, and I came up with these clips. And also there's another clip that holds the nylon sleeve to the bed. It may be difficult to see it, but it's right here. This guy right here. This again snaps into the opening in the extrusion, and the nylon sleeve with the wires slides inside of it, holds the whole thing in place. So that's one thing, and I'm sorry I just don't have separate items, all these items outside of the printer. I didn't record them before putting them in the printer, so I had to show them to you right on the printer. But hopefully you were able to see them well enough. And another thing is I came across this nice bracket for the spool. So instead of the original bracket that just mounts into extrusion at one point, this one actually offsets the spool. I'll actually show you on the printer. So this is the front of the printer. This is lower left corner, and this bracket goes right here in my case. So the spool actually gets moved to fit within the frame of the printer. Of course, some spools may be bigger, they might not fit, but most of my spools will not stick outside of the frame of the printer. So again, reducing the footprint of this printer. So that's one thing. And then this is actually available on Thingiverse already. I designed this thing a long while ago. This is a little spinny that you can put on your spool axis. Put your filament spool on top of that. Cap it off with another one of these, and then spool just nicely rotates, smoothly rotates on these. They have each has 2 bearings on it, 608 bearings, your typical 3D printing bearings. And so the extruder doesn't really have to pull very hard. A lot of printers, people just stick their filament on a rod like this without any kind of spinner, and so the extruder has to pull the whole weight of the spool to rotate it as it pulls in the filament. That, I think, causes some print issues, depending on whether the filament has to pull, or maybe the spool already rotated a little bit and the filament got looser on the spool. The thickness of the filament may be thinner or thicker. So I think it's good to have the filament come off the spool in consistent, smooth fashion. So I think that's all for the hardware bits and pieces. The printer, as you can see, is all good to go. It's all assembled. And I've done some initial tests. There will be some tuning needed to get this printer printing smoothly. Right now the printouts aren't the best. This is one of the test prints that I made. Your typical cross. I know I'm supposed to print a benchy boat, but I wanted to print something even smaller and faster, just to get initial idea of what's going on with the printer, what needs to be adjusted. And as you can see, there are some issues, and this may be tricky because this is the first time that I'm using 0.2 millimeter nozzle, which is very small. So this may require a little more tuning to get this thing printing right than your average 0.4 millimeter nozzle printer. So that's it for the hardware, and let's move on to the software.
Now let's take a look at the software. To compile new firmware for your Hypercube, you will need to install Marlin firmware. I'm using Marlin version 102-1, and to compile it, you need Arduino. Besides that, because of the CPU that Printrbot uses, you need to install support for Teensy 2.0 board. I'll provide a link in the description of where to download the Teensy Arduino software, and you just follow the steps in the instructions. Very simple. One thing that you need to pay attention to is that this software only supports certain versions of Arduino IDE, so you need to make sure that one of these versions is installed before installing Teensy Arduino. Once you've installed your Arduino and Teensy Arduino, when you open Arduino IDE, under Tools, you will see that you have a number of Teensy boards listed, and you select again Teensy 2.0. You need to make sure that USB type is set to serial. Initially, I had USB type set to row HID, and the printer was not responding. The serial port was not appearing for me in Device Manager. and then I realized that this needed to be set to serial. The CPU's speed needs to be set to 16 megahertz. Now, unfortunately, even though you can compile your firmware using Arduino, I wasn't able to upload this sketch using the upload button to Printrbot. To do that, you need to install another tool called Atmel Flip. And you can download it from Atmel's website. So make sure that you download that and install it and have it ready. You will need to find your compiled hex file to use it with the Atmel Flip. And to help you find that hex file, make sure that you go under File to Preferences in Arduino IDE, and make sure that Show Verbose Output During Compilation is checked. This box needs to be checked. So that prepares your Arduino IDE to compile your firmware. Now let's take a look at the changes that I made in configuration.h for my particular build of the printer. I always switch baud rate to 1152. That works better for me. Using 250,000 was just too fast, and there were problems with communication between printer and the computer, so this speed works better. Make sure that you select your board, printer board. This board has two thermistors. Has one for temp sensor 0, and if you have a heated bed, then you have temp sensor bed. Make sure that the other two temp sensors are set to 0 unless you've installed additional sensors, although that will be tricky because there are only two connectors for the temp sensors, but maybe there's a way to hook that up to the extra pins that are available on the board. I'm not sure, I haven't researched that. I usually set my temp residency time to 5 instead of 10. It just means that the printer will sit idle for a shorter period of time while making sure that temperatures that you've selected are reached and stay at that range. You can go with the default PID settings to start with, and then once your printer is built and ready to go, you can issue M303 command to run PID auto tuning for your extruder or hot end and heated bed, and then it will this command will output the values that you can then add to your configuration file, and those will be optimized for your particular hot end and bed. So that's what I did. I issued M303E0 for extruder number 0. C8 means 8 cycles, and S240 is the temperature in Celsius at which the measurement will be made. So after 8 cycles of testing and tuning, the final values will be output by the procedure, and that's what you enter here. Same for the bed. The command will be different. It's M303E-1, C8, and S90. You enter that and obtain correct PID values for your specific printer. For the end stops, if you use the kind of end stops that are popular on eBay, little red PCB with a switch and an LED and a 4-pin connector with 3 wires connected to that, then you need to make sure that your end stop sensors are set to inverting true. That's for X, Y, and Z. Also for your motors, make sure that your invert X, Y, and Z there is set to true, And if you're using the same extruder that I'm using on my printer, then the extruder motor direction invert is set to false. For the aluminum extrusions that I used for my printer, I ended up with these dimensions for my maximum travel for my X, Y, and Z. X is 177, Y is 105, and Z is 110. And for your default axis steps per unit, I used GT2 belt with 16 tooth pulleys, and for that the number will be 100 for X and Y. And the way you calculate this is you multiply your steps per revolution of the motor, which usually is 200. You multiply that by microstepping, and then you divide this by the tooth spacing on the belt multiplied by number of teeth. On your pulley. So in my particular case, I used 200 step motors times 16 microsteps is what's hard-coded kind of on the board. There's a little jumper pad next to each driver that you can cut the traces on, and then you will reduce your microsteps. About 16 microsteps is the optimal number. And then tooth spacing for GT2 belt is 2 millimeter and multiplied by 16 teeth of my pulley, and that equals to 100. For the Z-axis, again, 200 steps times 16 microsteps divided by the distance traveled in one revolution of your threaded rod. For my particular rod, it's 2 millimeters per revolution. And for the extruder, this number, 598.34, seems to be the correct number for my particular bolt. You have to experiment with this a little bit, but this will probably be a good starting point. And then you can measure how much filament is extruded and adjust this number accordingly. There are procedures described on the internet on how to calibrate your extruder steps per unit. Make sure that define custom M codes is enabled, and also define EEPROM settings. This will allow you to store your updated corrected values in the EEPROM without the need to recompile the firmware each time that you want to change something. And that was pretty much it. I started playing with enabling LCD, but I ran into problems when compiling firmware with LCD support enabled. So for now I've disabled that, and I will research this in the future. So these are the changes that I made, and I can now verify my code. And actually, for this particular version of Marlin, I will run into an issue, which is a conflict between this source code and C libraries that are being used by Arduino. So if you see this error message using type def name fpos_t after struct, that means that the firmware that you're using combined with your version of Arduino has this bug. So look for fpos_t error message, and all it means is that all you need to do to change or to adjust for this issue is to edit SdBaseFile and look for fpos_t, and replace any occurrence of this with any other name that you want. It can be just adding numeral 1 or A or whatever to this name. So turn f plus t to f plus t1. And actually, I'm not sure why this has numeral 1 appended to it. I was playing with this firmware back and forth, and for this demo I thought I reverted all my changes where I changed this to f plus t1, but apparently not here. So I'm going to edit this file and also SdBaseFile.cpp and SdBaseFile.h. You have to also find all these occurrences of f plus t and replace them with t1. So I'll edit this. I'll make sure that all these are correct, and then your code will compile. Alright, now that I've replaced fpost underscore t with fpos underscore t1, my code compiles cleanly, and at the end this window pops up, which you would use to program your board if that process worked. Unfortunately it doesn't, and actually one thing that I see here is that it says Marlin.ino.hex too large. So I'm thinking that maybe Teensy software thinks that the resulting firmware is too large to be programmed onto the chip, which that's incorrect, because Sketch uses 69 kilobytes, which is 53% of the maximum chip capacity of 130 kilobytes, or 128 to be exact. But anyway, so we cannot use this Arduino software to program Printrbot. What we need to do is locate the hex file that was produced, and that's why you needed to enable that displaying the messages in preferences. With that enabled, you'll see on your screen that the output path, you just need to look for the last line of compilation, look for word path equals and then the path to the build directory. You need to find something in that directory that's called Arduino build and then the number, whatever that number is. Look for that in your temp directory. And this is a lengthy path, so I would just move this the file that sits in at this path to some more convenient location where you don't have to navigate through all these sub-levels of directories. And the file name that you're looking for is marlin.ino.hex. So once you find your marlin.ino.hex file, you open your Flip software, go under File to Load Hex File, and you locate that file and load it. And as you can see, I've played with some different versions of this firmware, but I'll select the one that I've just compiled. You go under Device to select and make sure that AT90 USB 1286 is selected. That's the chip on the printer board. Then you go under Settings to Communication USB and select Open. But before you do this, before you click on Open, you need to put a jumper on two pins which are located right next to your CPU. So on the printer board, look at the biggest chip on the board, that's the CPU. Next to it, there are two pins. Put a jumper on those pins and then push a reset button. So I'm going to do that now. So that jumper placed on those two pins plus pushing of the reset button puts your Printrbot in the programming mode. Once you do that, you can select Open. That establishes connection to your CPU, and you click on Run, which will erase, program, and verify your hex code into the CPU. And verify pass means that your programming completed successfully. You can close your flip software, remove the jumper, and press the reset button again. Once you've removed the jumper and pushed the reset button on the printer board, you will see that you have a new COM port called Teensy USB serial, and then COM and a number at the end. That's the COM port that you will use in your Repetier or whatever software that you're using to communicate with this board. So let's take a look at Repetier host. I'm already connected to my printer, and I don't want to get in too deep into configuring the printer, but basically you need to go to Connection tab, select your port, COM33 in my case, select your baud rate. These settings will mostly be OK, default. Extruder, make sure that you select 0.2 if that's the extruder size that you're using, or the nozzle size that you're using. That's what I'm using in my case. So just make sure that that's correct. And then if you use the dimensions of the aluminum extrusions that I used for my build, then most likely you will end up with these numbers in here. With my X extrusions, I ended up with some extra space on either side of the bed, and so you need to set bed left value of 17. That's the extra space to the left of the bed, and I have another 17 millimeters to the right of the bed. And bed front is 7. And then your print area width is 140, depth 98, and height is 110. And the maximum travel for your X and Y is 177 for X and 105 for Y. I wanted to have extra space on my X axis so that if I decide to use a different size of extruder, maybe dual extruder, or maybe direct extruder mounted directly on my X carriage for flexible filament, you cannot use Bowden extruders, you have to go with direct extrusion. So I wanted to have some extra space to allow for this. And again, you connect to your printer, and once you're connected, you can issue some commands to verify some values and settings. So let's take a look at what the current settings on my printer are. M503 is what will display your settings, and this is what I showed earlier in Arduino IDE, your steps per unit, X100, Y100, Z 1600, which again that's the result of that calculation of number of steps per revolution on the motor times microsteps divided by the travel per revolution. And again 598.34 for my extruder. And your acceleration, feed rates, all that is here, along with last line PID settings, M301, P19.25, and so on. This is what I obtained when I calculated or calibrated my firmware using AutoTune. And again, that's in config.h. If you go to your PID section, that's where you'll find, where was that? Here. You'll find the command to use to do the AutoTune. But basically it's M303, E, the number of the extruder, C count equals 8, and S for temperature. And again, if you change anything on your printer and you need to adjust for these new values, you don't necessarily have to compile your firmware. If my PID settings changed, all I would have to do is execute M503 to make note of whatever my current settings are, and then execute the command to change those values. So if I do M301 P10 I5 D20, or whatever the numbers that I want to use, if I send this to my printer, then my PID settings will be changed. The only problem is that Marlin doesn't really support setting PID for the heated bed. You can only change this value for your extruder. So if you change your heated bed, then that would be something that you would have to recompile the firmware for to make that adjustment. But other than that, for your hot end, you can change your PID, you can change your steps per units if you change your motors, or your threaded rod for the Z-axis. You can adjust all that. And once all this is set and completed, all that's left to do is just calibrate this printer, tune it, make sure that the bed is level, that your Z position for the home position is correct, that your filament gets extruded in a nice even layer. Just some basic tuning that if you're doing builds of 3D printers, then you should be already familiar with. So that's it for this.